Hi guys, welcome to your Chapter 6, Lesson 5 notes on linear inequalities. Yes, you heard that right, inequalities. Let's jump right in. Await objective. By the end of the day, you'll be able to graph linear inequalities in two variables. You will also be able to use them to model real-life situations. Okay, cool, but what is a linear inequality? Besides being a phrase that's really fun to say, a linear inequality is exactly what it sounds like. It's a line that expresses something that is unequal, also known as not equal. Okay, so it's a line that's not equal to something. So a linear inequality, just like a linear equation, has two variables, usually x and y. But you form a linear inequality by replacing your equal sign. So if you have if we have a line, y equals x minus 3, okay, that's a line. It's got an x, it's got a y, okie dokie, cool. We'd have a solution here that fits in an ordered pair. But instead of being an equality, we get rid of this equals and we replace it with an inequality, with a greater than or a less than or something. That's it. That's literally how you make a linear inequality. You got an x, you got a y, you got an inequality. Okay, so we talked earlier about having a solution. The solution of a line is an xy pair. Same thing. The solution of an inequality is still going to be an xy pair that makes your inequality true. So, you know what? Instead of looking at examples, instead of making up examples, let's just look at our first example right here and see if pairs are going to be a solution. Okay, so we've got our inequality. Y is greater than x minus 3. And we want to figure out, hey, does this ordered pair, does this x and this y, would that make the equation true? And by equation, I mean inequality. So let's go ahead and plug them in. This means we would have 2 is greater than 1 minus 3. 1 minus 3 is negative 2, in case you were wondering. So is it true that 2 is greater than negative 2? Yes, that's true. So 1, 2 is an equation, not an equation. It's a solution to this inequality. Let's do that same process with our second point. Again, we've got an x, we've got a y. Let's see if this makes the inequality true. Is it true that negative 7 is greater than negative 3 minus 3? Well, negative 3 minus 3 is negative 6. So is negative 7 greater than negative 6? No, it is not. It is less than negative 6. So this is not a solution of the inequality. We found solutions of lines before by graphing the whole line. Let's do the same thing here. Now, how you graph an inequality is you have to cover every single point that makes this true. So I'm just going to tell you how we do it. If you want to get the y, you can ask me in class. Our first step is going to be graphing the line. We'll have 2 more steps after that. Okay, so we want to graph it like it's a line. We want to graph the line y equals x minus 2. So I see that it's got a y-intercept of negative 2. It's got a slope of 1, so it's going to go up 1 over 1, up 1 over 1, just like that. So I'm going to graph this line, and wow, that missed. Okay, cool. There's my line. But that's not all you do, because you actually need to say, is this going to be dotted or solid? So your second step is to ask yourself, is this going to be a dotted line or is it going to be a solid line? So when you look at this inequality, y is greater than x minus 2. Right now we graphed the equation y is x minus 2, but these points don't make it true. For example, if we plugged in our y-intercept right here where y is negative 2, x is 0. -2 is not greater than -2. This does not make it true. So in fact, what we have to do is we have to erase that point. That doesn't make it true. In fact, this whole line doesn't make it true, but it's right on the boundary. We call this the boundary line. We're going to make it dotted because everything up to this line makes it true. So we need to make this a dashed line because we have a strict inequality. We'll look at a different one later. So we actually need to make this line a dotted line. Ta-da! And now we need to figure out what points actually do make this equation true. So we need to test a point that will tell us what side of the line to shade. So let's find a good checkpoint. And of course, always go for the easiest point. The easiest point in this case is 0, 0. So we want to figure out, does that point make the equation true? Is it true that 0 is greater than 0 minus 2? Is 0 greater than -2? Yes, that is true. So we're going to plug that guy in. I'm sorry, we already did plug him in. We know that that makes him true, so we're going to shade this whole side of the line because all the points on this side of the line, and this half plane is what we call it because it's half of a plane, boom. And that's how you graph it. I guess I should make this line blue too. Ta-da! Let's do our next one. We're going to start out, our first step here is to graph this line, is to graph the line y equals 3/4 x minus 2. So we start at -2. We go up 3 over 4, and there's our point. So we're going to draw our line through here. Ta-da! Amazing. Now, we graphed the line. Is it a dotted or is it a solid line? Because it has an equals, because it has an equal to, this equal to means it's going to stay a solid line. So we'll keep it solid. And now we need to use a checkpoint. We need to figure out what side of the line do we need to shade. So let's use 0, 0 again, because that's easy. So we get 0 is less than or equal to 3/4 of 0 minus 2. Is it true that 0 is less than or equal to negative? No, that's not true. That's not a solution. We can't shade that side. Fortunately, lines only have, 2 sides to them. So we just shade the other side. Yay. Okay. You could double check by picking a point over here, like picking 5, -5, and seeing if that makes it work. Spoiler alert, it does. So that's exciting. Isn't that great? That's so great. Same thing applies to vertical and horizontal lines. If you have x equals, sorry, not equal, if you have x is greater than -1, start out by graphing the line x equals -1. That's this guy right here. But remember, there's no equals here. It's just greater than. So this means it needs to be a dashed line. If you're working in Notability, you can use this pencil tool up here. You can shift over, and you can pick either this dashed or the dotted. I like to go with dashed. I just changed my mind. Okay, right. So this time you put it over x equals -1. Draw your little arrow guy. Hey, there's your dotted line. Now you need to figure out where x is greater than -1. You could plug 0, 0 in here. Is it true that 0 is greater than -1? Yes, haha. Or since it's literally just, x is greater than -1, you just cover wherever the x's are greater than -1, which is all of these guys over here. Ta-da! If you don't have a highlighter to work with, I'll show you another way to shade using just a pencil. Here, same thing. We got to graph y is greater than or equal to 2. So we'll graph the line y is 2. Here we're going to keep it solid because we have an equals to. So that is a solid line. Now y is greater than or equal to 2. Let's use a test point. Oh, right. We're using a pencil, no highlighter. 0, 0. Is it true that 0 is greater than or equal to 2? No, that is not true. So instead, you can just use like some scribbles and shade that part like that. That's fine, but I much prefer the highlighter. It just looks so much better, doesn't it? Cool. Cool. Okay, we have one more. When are we going to use this in real life? Well, I'll tell you. Let's say that you're going to redo your kitchen and you have this wall above the counter, and it's going to be redone where you have tile over here. You have 12 square feet of tile, and then you have 24 square feet of paper, and you can spend $420 or less than that. You write a linear equality and graph its solutions. This will help you figure out prices for wallpaper and tiles. Okay, we know we can spend a total of $420. So we'll start that out by saying, okay, 420 is going to be equal to whatever our tile price is, 12 times the amount of tile we have, and 24 times the amount of paper we have. Now we need to figure out, okay, what does x represent? Here x represents the square. Oh no, x represents the price. I'm sorry, the price of the tile. We'll multiply that by 12 because however much the tile costs, we'll need 12 square feet of it. And y is going to represent the price of the paper and wallpaper, right? Because this paper we put on a wall. And this is going to be 24 times the price. We'll pay whatever the price of our paper is. We're going to need 24 square feet of it. Add them together, and then we've got our total price is 420. It needs to be, our price needs to be less than that, but it can be equal to, because it can spend 420 or less than that. So our price needs to be less than $420. Awesome. Now we can graph it. We'll graph it by putting it in standard form. Oh, hey, look, it's in standard form. So we'll want to graph the line 420 equals 12x plus 24. When we do that, 24y. To find our x-intercept, we'll pretend that y doesn't exist. So say 420 equals 12x, divide by 12 on both sides, and we will, get that x equals 17? Is that right? I think I switched them around. 420 divided by 12. Yep, I did switch them around. Is 35. And then to find a y-intercept, we're going to pretend like x doesn't exist. So say 420 equals no x's, but 24y. Divide by 24 on both sides. To get that y equals, that's going to be my 17.5 price. So now we can put them on our graph, but I will need to fix my labels. X is going to go all the way out to 35. So what if we just make this 40? Yeah. Which means this is 20. That's 10. That's 30. And then y needs to go all the way up to, let's make this 20. Let's also make this completely vertical. Okay, this is 20. This is 10. 12, 14, 16, 18. Haha! Nailed it. Okay, so remember what x stood for? X is the price of the tile. So in saying that x is 35 when y equals 0, this means that we can buy $35 tile if our paper is free, if we don't buy any paper. Alternatively, in finding our y-intercept, remember y is the price of paper. So if we get paper that is $17.50 per square foot, we will have no budget left for tile. Ideally, we'll find something in the middle. Let's finish our graph by connecting our x-intercept and our y-intercept. That was not a straight line, but we're gonna count it. It's gonna be close enough. Okay, we're almost done with our graph. Now we need to test a point. Let's go with 0, 0. Now I'm gonna wager that 0, 0 is gonna make this equation true, but let's plug it in anyway. Is it true, if we plug in 0, 0 for our x and our y, is it true that 420 is greater than 12 times 0, which is 0 plus 0? 420 is greater than 0? Oh yeah, sweet. That makes it true. So that means we're going to shade this part of our graph so we can spend anywhere underneath this line. Yay! So any of these points will make it true. If we get, tile that's worth $10 and paper that's worth $5, we can afford that. Or even if we get one that's right on the line, if we spend $20 on tile and $8 on paper, we can afford that. Oh, I should be writing this down. I'm so sorry. Okay. So again, we've got tile followed by paper. If we spend, here, what is this? Over 10 up 5. If we spend $10 per square foot on tile, we can spend $5 per square foot on paper. If we spend $20 per square foot on tile, we can spend $8 per square foot on paper. If we spend, let's go all out, let's get free paper. Okay, if we spend $35 on tile, we will have nothing left for our paper budget. Hopefully it will be donated. So there you go. This is how we can use inequalities in real life. A lot of it is comparing costs. Some of it will be comparing. You know what? I'm not even going to spoil it. I'll let you discover in your homework. I hope you have an excellent time. Remember to graph the line. Make sure it's dotted or solid. And then use a checkpoint to throw some shade.